In recent years, Ghaziabad has grown rapidly with new factories, power plants, and residential complexes transforming the city's landscape. But alongside this development, a serious challenge has emerged: air pollution and water contamination. One of the major sources of air pollution is the power sector, which releases gases like carbon dioxide, sulfur dioxide, and particulate matters such as soot and ash during fuel combustion. These pollutants come mainly from thermal power plants and industrial units that depend on fossil fuels. Unfortunately, pollution control systems in many of these areas are either outdated or too expensive, which makes the problem worse. At the time, untreated wastewater flows openly through city drains. This water, mixed with domestic and industrial waste, often reaches local water bodies, contaminating them with chemicals, organic matter, and pathogens. What's the result? An unhygienic environment, foul odor, and increased cases of respiratory and waterborne diseases. Local residents living near industrial zones and open drains suffer the more. They face poor air quality, unsafe water, and health issues every single day. That's where our team decided to act, to find one integrated, eco friendly solution to tackle both air and water pollution together.
Greetings everyone, this side Divita Tyagi from Gurukul the School, Ghaziabad. Our solution is called BioLumea, the algae powered street lamp. It is a model that purifies water waste and generates clean electricity simultaneously using the natural power of algae.
Hello everyone, I'm Sanika Banerjee and let me tell you about our model. So our model consists of four main components and let me show you how each of them play a crucial role. So as you can see here, this is the model of our algae powered street lamp. Let me show you the first component, that is the bioreactor chamber. This is the bioreactor chamber or compartment. Here it basically introduces the wastewater. As we can see, here is the drain. The wastewater is pumped with a high power pump and it flows upwards through these pipes. As it reaches these pipes, it fills the wastewater into these particular compartments. It is transparent, as the transparency allows the sunlight to reach the algae efficiently, helping them to grow. Now, you may ask why we chose wastewater. It is because wastewater contains nutrients like nitrates or phosphates, which the algae uses naturally. Here, the red boxes symbolize the anode and the blue boxes symbolize the cathode. This is part of the electrode chamber. Now let us just continue with the bioreactor chamber. Here inside here, it oxidation occurs. The algae converts organic matter into CO2, H plus and electrons. So the anode, which is placed inside each of these compartments, captures the released electrons, and this turns the chemical energy into electrical energy. So now that we have finished the bioreactor, let us move on to the electrode chamber. Let me just move it a bit. Here we can see are the cathode compartments. Basically, these cathodes, they are containing treated purified water in which oxygen is dissolved. The electrons which flow from the anode, they flow through an external wire to the cathode chamber. That this is the cathode chamber, and here the blue boxes symbolize the cathodes. The protons, they travel through a salt bridge which connects the electrode chamber to the bioreactor. Now, as we said, instead of the aerated air, we use treated purified water. And here we see a reaction taking place. The oxygen dissolved in the treated water reacts with the electrons and protons to form water H2O, and this therefore completes the circuit. And this reaction enables continuous electricity, and therefore this makes this whole system function like a biological battery. Using the treated water, it helps maintain a closed looped system, and it conserves resources and eliminates the need for artificial aeration. Now, going on, since we know that the algae, it uses the sunlight for photosynthesis, and it breaks down the wastewater. Here, while the algae generates electricity, it also absorbs heavy metals and pollutants from the wastewater. So basically, the treated water, which is treated by the algae, it passes through two filters. At first, it passes through a pipe, as we can see. Let me just bring this down. We can see here that it passes from this pipe into the filtration unit. Here there are two filters. The first, it removes solid and suspended particles, whereas the second, it is made up of activated carbon, and therefore it eliminates odor, toxins, and chemical impurities. The purified water can be later on again used for irrigation or cleaning or gardening. Moving on to the fourth compartment, or the fourth component, that is the LED light module. Here, the generated electricity is being stored in a battery that powers the LED lamp, and the LED sensor automatically turns it on at night and off during day. And to make it more reliable, we have also added a solar panel for backup power. This is the solar panel that you can see, and this is the solar panel which we use during cloudy days or when the algae output is low. So the process continues as long as sunlight and wastewater are available, and therefore this creates a self-sustaining cycle of energy and purification. This makes BioLumea special. Its ability to address two problems, that are water contamination and air pollution, as an integrated solution inspired by nature itself.
Greetings everyone, I'm Avni Garg, and when we talk about a project by Lumia, initially our electrodes were placed directly inside the algae chamber, but when we got feedbacks from our mentors, we included a separate electrode chamber which increased overall efficiency, made cleaning easier, as well as enhanced the electron flow, increasing overall power output. We also switched from clean water to wastewater, which made the system more practical and environmental beneficial. To make the water output even safer, we added the two-step unit filtration, and to ensure reliability, we integrated a solar panel backup. Of course, we faced many challenges during the making of this model, like scaling up the model for large areas, monitoring algae growth, and maintaining electrodes over time. But these challenges only encourage further research and innovation. So, through Biolumia, we try to showcase how biology and engineering can come together to create solutions which are more sustainable for cities like Ghaziabad. It's just not a street lamp, it's a symbol of environmental hope, water conservation, and clean energy, because the future of our cities depends not just on how much we build but on how sustainable we grow. Thank you.